Hello everyone. Welcome back. In the previous session, we have got an idea about the database, and various structures of databases, like SQL and NoSQL. Today, we are going to discuss how the database is designed for analytics. Specifically, we'll discuss on data warehouse, business intelligence, reporting, and data visualization. So, let's get started. For a moment, think of yourself as the CEO of a retail chain. Every day, there are hundreds of customers buying products from you. Several vendors are supplying products to your stores. Thousands of transactions are taking place across customers, vendors, and other stakeholders. So, you must be having a proper mechanism to capture and record all these data on a real-time basis. These are known as transaction data. Transaction data captures every detail of your business, as it happens. Examples are point of sales data, ERP, operations data, application data, and so on. Transaction data can be in SQL or NoSQL format, depending on what type of data you are capturing. Now, after some time, as the CEO of a retail chain, you may like to have an overall view of your business, like, how is it going, where is it going, and other specific queries, to help you make better decisions. For example, you may want to check if sales for sports shoes is increasing among the premium customers for the North region. Logically, you want to use your transaction data in the first place. So, you ask your data analyst to write a query to join sales, customer, and product data tables, and gather all relevant information in one place. And on top of that, ask her to run data commands to get answers for your specific queries. Now, there are some problems with this approach. First, when you want to join the multiple transaction data tables, the computation time is very high. Further, it cannot help if you have multiple such queries. Second, as you run your commands, your transaction database itself may become very slow, and create performance challenges. After all, transaction data is not designed for analytical purposes. Just to give a sense, Walmart has more than 1 million customer transactions every hour. So, think of the practical challenges of using transaction data for analysis. Hence, it requires to think of a different strategy. Here comes the concept of a data warehouse. So, how does it work? In simple terms, first you extract transaction data from all systems. Then, store it temporarily somewhere, where you clean, arrange, organize, and add on other calculated fields, as per your requirement. Then, load it in another database, known as data warehouse. So data warehouse is the single source of truth for analytical data. It is similar to a goods warehouse, where you store different products, and take some products as per your requirements. The process of archiving transaction data to data warehouse is called an ETL, or extract, transform, and load process. Here, the transaction data is first extracted from multiple systems at a certain defined frequency. Then, it is transformed as per business needs. And finally, it is loaded into the data warehouse. Talend and Informatica are popular ETL tools. Now, there may be few challenges with ETL process. ETL requires the raw data to store somewhere, where it gets processed, before it is loaded into the data warehouse. This may be a process bottleneck, if the data volume becomes very high. Moreover, if a different transformation logic is required to apply on the data, at a later stage, it becomes a challenge, as the raw data is not residing in the warehouse. In this sense, ELT, or extract, load, and transform, has been found a better process than ETL. Here data from multiple sources are extracted and loaded first into the data warehouse. The data is transformed later and this provides more flexibility, as both raw and transformed data are available. The transformation logic can be changed without impacting the system performance. Next, the question is, how analytical data is located in the data warehouse? Well, the data is arranged as a dimensional table. When you see a simple rectangular dataset, it is a two-dimensional data table. This can be of a higher dimension. For example, sales across customers, products, and time can be stored as a cube. It can be of even higher dimensions as well. An OLAP, or online analytical processing, is used to create this dimensional data. These are known as OLAP cube, which is nothing but a specific data structure. In a data warehouse, these cubes are pre-created and stored for ready-made analytical purposes. Once we have the data warehouse ready, with analytical data formatted as OLAP cube, it is time to use that for analytics purposes. Here comes business intelligence and reporting. The business intelligence and reporting tools sit on top of OLAP cubes and helps with quick descriptive and diagnostic analytics. That means it captures the information around what happened in the business and the core reasons behind them. For example, as the owner of your business, you must be interested in getting the answers to questions like, which customer segment buys the premium winter jackets? Which customer has stopped buying recently? How to improve Net Promoter Score in the US market? Should we offer a promo on sportswear? And so on. So we see that, with OLAP cubes, the data is ready for analytics, with all relevant data stored and organized in a very efficient manner. And the business intelligence and reporting tools can easily work on it to provide answers to all basic business questions. The business leaders are also interested to track business performance around certain key performance metrics, called KPI. Some widely used KPIs are revenue growth, order fulfillment rate, stock out rate, number of escalations, Net Promoter Score, customer churn rate, and cash flow. Business intelligence tools help creating customized summary reports around those KPI. In many cases, these reports are discussed in weekly business review meetings, and decisions are taken accordingly. Usually, the BI tools come with excellent visualization capability. These tools are used to create interactive dashboards around performance indicators, and help to create stories with trends, charts, heat maps, and several other features. Some great examples of BI tools are IBM's Cognos BI, Tableau, Microsoft Power BI, ClickView, and so on. Now, some BI tools are SQL dependent, while some other BI tools are not. For example, Tableau is a very popular BI tool with excellent reporting and visualization capability. And the good thing is that it does not require the user to have SQL knowledge. Similarly, the BI tools that work on OLAP Cube usually do not require SQL interface. Microsoft MDX language manages the job on a data cube. However, there are a few tools like Charito, Redash, and Holistics, which come with a powerful SQL query interface. Please note that business intelligence and business analytics are very widely used terms. They usually have quite an overlap. However, business analytics is much broader, and it also includes predictive analytics. Further, business analytics is a more general and trendy word, and it receives more search hits in the Google search engine. Let me summarize the discussion with some important notes. There are two types of data in business. One is transaction data, and the other is analytical data. Transaction data is more to run your business, while analytical data is to manage your business better. Fundamentally, transaction systems are designed to fetch all columns for few rows, while analytical systems require all rows for few columns. Hence, The transaction database is not designed for analytical purposes, and vice versa. So, it makes every sense to handle them separately, specifically for large enterprises. The data warehouse is to archive transaction data in a format suitable for analytical purposes. On top of a data warehouse, we have BI tools to extract information and knowledge as per business requirements. Examples of the popular data warehouse are Google BigQuery, Amazon Redshift, and Snowflake. These come with in-memory processing and columnar architecture. Hence they are very efficient for analytical purposes. So hopefully this gives you a good idea of data warehouse and business intelligence. In the next session we'll discuss about big data. Stay tuned, and I will speak to you soon. Thank you.